So, as mentioned, Jupiter has lots and lots and lots of moons. We're only going to look at the biggest 4, and these 4 are readily visible when you look at Jupiter through a basic telescope like the one I have in the back. This is a little close-up of the 2. Io, Europa, Ganymede, and Callisto. The first moon that we're going to look at is the beautiful Io. You can go ahead and write this down. Io. I suppose it'd be funnier if it was LOL. So, we talked last time that the Greek equivalent of Jupiter is Zeus. What was one of the things that Zeus is kind of known for?
Is this?
Lightning is one. What was another thing?
Having many wives.
Yes, he had many, many, many wives. So one of the good things about astronomy is that when they name planets and moons and stuff, they try and keep it consistent with the mythology. So most of the moons of Jupiter are named after Jupiter's mistresses. And if you know anything about Zeus from your literature and history classes and stuff, you know he was quite the character. He had an affair with Io. You don't have to write this down. And then he changed her into a cow to avoid suspicion.
No, he had a side cap.
So, yeah. I mean, what else would you do, right? It's like this is the first time Io saw herself in the mirror. What? You can skip this slide too. But we've got 2,260 miles across. So this is a pretty good-sized moon. Write this down, though. In the background, you can see Jupiter there. This isn't quite accurate. Jupiter would be much bigger than this if you were standing on Io, the closest place to Jupiter. And that picture you'll see a little bit better in the next slide. Gives you an idea of how close this moon actually is to Jupiter. Right there. You can write this whole thing down. So Jupiter would take up most of the sky if you're standing on Io.
Are we supposed to write this down?
Yep. 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 So we're still on Io here.
Yeah, I know.
So if you're the type of a person that's really into volcanoes and eruptions and things like that, Io would be your place, the most volcanically active body in the entire solar system. And the reason it's so active is because it's being pulled on in two different directions. It's being pulled by Jupiter one way, and it's being pulled on by Europa, which is the next moon out, the other way. And so it's this constant tug of war going on. And if you've ever taken a paper clip and you bend it back and forth and back and forth and back and forth and back and forth right before it breaks, do you notice anything about the temperature of that paper clip? Yeah, what do you notice? It gets warmer. Same thing is true if you take a rubber band and you just kind of keep stretching it back and forth like this. If after you do this for a little while, you hold it to your face, you'll be able to tell that it's warmed up quite a bit. And that's what's going on inside Io. It's constantly being pulled on, constantly being tugged on, and so that heats up the interior, and you have all that volcanic activity. You guys know how to shoot these things? Good stuff. Okay. Io is actually one of the best examples of our solar system being young, because if Io was billions of years old and made in the way that the scientific community thinks that everything was made through the Big Bang, it would have run out of volcanic material long, long ago. You can write this slide down too. And this is an actual picture of an eruption occurring on Io right here. Gives you an idea of how strong some of these eruptions can be. It goes up real far, and eventually it just loses steam and starts to fall back down to the moon. But even with that tug of war, eventually you're going to run out of stuff that's going to erupt. And that should have happened a long, 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 long time ago. And a little picture of Io right here. You can see Jupiter in the background, so it's obviously tiny compared with Jupiter there. What's that?
Looks like a potato.
It kind of does look like a potato. An ugly potato. The surface of Io, again, you've got lots of volcanic activity. And it's not the magma that we're used to on Earth. It's not the same material, melted rock. This is more sulfuric. So it'd be a little bit more yellowish, kind of like this picture right here. So it's a very hellish place. It's not the sort of place you'd want to spend a vacation, that's for sure. A little picture of one of those eruptions. This is not a real picture, just artistic representation. The next moon out that we're going to talk about is Europa. You can write this down. This one looks kind of like a cracked egg. It's one of the more popular moons. NASA is interested in sending missions to two different moons in the solar system. One is Europa, and the other is one of the moons on Saturn. We'll talk about that later. Yes? Sure. October 2nd, 1255. So, Jupiter, being Jupiter, has done his thing with Europa too. He thought she was pretty attractive, so he turned himself into a bull and carried her on his back from Asia to Europe. Because that's what you do when you find a lady attractive. Thus, this moon is named after one of his mistresses as well. You don't have to write this down, but nice little trivia there. You can skip the size, but Europa is also pretty big, 2,000 miles across. It's not as big as Io, but it's still up there. You can write this one down, though. This is one of the reasons that everybody's so interested in going to Europa. This just means when you look at Europa, the white stuff is ice, and the red stuff is mineral-rich water that came up and then froze. And this is why Europa has that kind of cracked egg look to it. It's not just icy, but there's lots of cracks, and that material has come up from underneath and frozen on the surface. Kind of like Jupiter's clouds. Jupiter's clouds, a lot of that dark material was brought up through convection from the inside of that planet. This is a nice little view of what it might look like from Europa. You can see the white ice and stuff there. Pretty good representation of how bright the sun would be from this distance. And a pretty good representation of what it would be looking at Jupiter and Io if you're standing on Europa. And you can write this down as well.
What the?
And so this is the other big reason that everybody wants to try and send a probe to Europa, because you've got ice here, and just underneath that ice, it might be warm enough for there to be an ocean. And nobody knows what we'd find there, what the composition of that liquid would be, if it would actually be water, if it would be some other sort of material. Of course, people assume that there might be life down there, but it would be interesting to see what would happen if we would drill down. Now, the tough part about all this is we don't know how thick this ice is. It could be anywhere from 100 yards deep to 100 miles deep. So that's what makes it difficult to try and send something with the purpose of drilling down far enough. But this is the sort of thing that you see in textbooks when you look at what's going on Europa. You got this ice covering. There's probably some sort of liquid water underneath it, but we don't know how thick this ice covering could be. And so it's speculated on what it would look like underneath. No one really knows, but it'd be really cool to find out one day. Third moon, Ganymede. A lot of really important things about this moon. No good stories from Jupiter on this one. This is actually the only moon of Jupiter that is not named after one of his mistresses. So for that reason, you can write this slide down as well. Yes. One of the other cool things about Ganymede, and you'll find this out in a later slide, I'll have you write it down, but it's actually the largest moon in the entire solar system. So it's important to know its size. Go ahead and write down the diameter. Hi, guys. Feel free to take pictures, that's fine. So 3,270 miles across. So it's a little bit more than a third the size of the Earth. So it's still like moon-sized and everything, but it is the biggest moon in the entire solar system. So it is important that you know this number. You can write this down too.
This is all for the third.
Yep, this is all for Ganymede here. So Ganymede is unlike the other two moons of Jupiter. Of course, Io was the very sulfuric volcanic one. Had a very sulfuric surface. Europa had that icy surface. Here we've just got rock and ice. A little bit less interesting on the surface of Ganymede. Could look something like this. In the distance you can see Europa here and Io there. Pretty good description of how big Jupiter would look from that position. And more important information there. You can write this down. You can skip the bottom one. Just the first two bullet points. So again, Ganymede is the largest moon in the solar system. That's an important fact. Also, it's the only moon in the solar system that actually has a full-on magnetic field, which is interesting because even some planets don't even have magnetic fields. Places like Mars, places like Venus, places like even Mercury is very, very weak. And so for a moon to actually have a magnetic field is big, big news. So this last bullet point here, where it talks about the saltwater ocean that might exist far below the surface, it's not like we've drilled down that far and we can like hear it shaking the water around or something like that. The reason they think this is because we can measure the average density of these places based on rotation, based on orbit, and a couple other things. And they noticed that the average density of Ganymede is much less than if it was just mostly a rocky world like Mercury and like Mars and like Earth. So because it has a much smaller number than they think, they figure maybe there's just a big, big liquid ocean underneath the surface. It's not the sort of thing that we've tested directly, it's just an idea. I think that's it for Ganymede. On to the last moon that we're going to look at, Callisto. So, as mentioned, Ganymede was the only moon not named after one of Jupiter's mistresses. So Callisto is. She was raped by Jupiter, then got turned into a bear. So, yeah, that moon's named after another mistress there. You don't have to write this down. Seems like the moral of the story is if you're a lady and somebody says that they're a god, just walk away. What's that? Right, right. You don't have to write down the diameter here, but Callisto is a very, very large moon, 3,000 miles across. You can write down its surface, though. Cratered and rocky. Looks something like this. A view of Jupiter from this distance would look something like this. So it's still very prominent in the sky, really cool view, but you would not be able to, it's not going to take up a large portion of your sky like the other moons. You can write this information down, but you can once again skip the ocean that's supposedly below the surface. They think it's there for the same reason that they think it's there on Ganymede. Valhalla crater is the big thing on Callisto, 224 miles across. A little bit smaller than the size of Wisconsin. Yeah, not the oceans, just Valhalla crater and how big that crater is. There's just a couple other interesting things about Callisto. This is an interesting feature that Callisto has right here. You can kind of see that there's this ridge here, and if we were to back up, it would look like this. And so the question is, how the heck did this get here? It looks like you have these craters all occurring in a straight line, one after the other. So that's one of the big mysteries about Callisto. We don't really know how that happened. It could have been maybe a comet or a meteor that broke up and then just subsequently hit one after the other on the surface of Callisto, but it's an interesting little feature there. This is also interesting. If you're going to go to Jupiter, and you can write this down, if you're going to go to Jupiter, Callisto is the only place you could really observe it from. So the reason you've got radiation issues on the other moons of Jupiter is because you got to kind of know how stars work. So stars give off light and heat because there's enough pressure on the inside that it fuses hydrogen atoms together, and that causes a nuclear reaction, like a mini atomic bomb explosion. So that's where stars get their power from. And the bigger the star, the more powerful those reactions are. Jupiter is big enough that it actually has this occurring on a small scale. And so because you've got those nuclear reactions occurring, you've got radiation coming off of Jupiter. And the closer you are to Jupiter, the more you're exposed to that radiation. If you're far enough away so that you're on Callisto, then it's not going to affect you all that much. But if you make a base anywhere closer than Callisto on one of those other three moons that we talked about, radiation is going to be a big, big issue for you. So if we ever wanted to do Jovian exploration of Jupiter, we'd have to do it from Callisto. I think you can probably skip this. Let me see. Yeah. So these moons are easily visible with binoculars or a telescope. If you just have a little pair of binoculars and you look at Jupiter, you're going to see Jupiter as kind of a little white disk, and then to the sides of that disk you would see 4 stars, and those stars would be the moons of Jupiter. This is the sort of thing it would look like with the telescope in the back of the room. Now, one other thing that's important to know for the quiz on Monday is the order of these moons. So it looks like from this picture, this is the closest one. Which moon would this be? Yeah, we got Io there. Looks like this one's probably the next closest. What's that one? Yep. This one looks like it's the biggest. Which one's that? Yeah, the one that starts with a G. Ganymede, yep. And last but not least, we've got Callisto. See what I did there? Okay. And we got our family portrait there. That does not match up with the names. So yeah, study your stuff. We'll have a quiz on the moons of Jupiter on Monday. Yes.